Alright, so first I had to run my RVC startup to run the robotic toolkit, and then second I had to run the Arduino, and you can see both robotics was ran and so was the Arduino. Next I'll open my script, and here's my GUI. I'll go ahead and connect the Arduino, and I'll need my COM, which I got from the Arduino by connecting on the upload. And here's my COM, which looks a little different because this is a Mac. USB modem 1411, and then we can see over here that it's attempting connection. Back to the GUI. Arduino port successfully opened, so now we're connected. I'll go ahead and move this without connecting my hardware over here. I'll show my 3 arms which we made in project 1. This is mine, AW1980 arm. This is the Puma 560 arm, and finally the Stanford arm. You can see all 6 joints. And moving, it take a little time sometimes to move. Then I'll show my arm, the one that I made. Moving without the hardware. You can also see the track of how the arm moves. I'm doing a little fast, so if I go a little slower, you can see the track better. We'll go ahead and put the joints back to how the arm was originally. By selecting the arm, it deletes all the track. Next, I want to show you the connect hardware, which I'll go ahead and connect hardware. Now, it didn't give me a message saying you must connect hardware first because I already connected it from the Arduino. Enter step size, I'll go ahead and say 80. Okay. Enter joint 1 through 6, I'll go ahead and say joint 5. Okay. And I'll take the potentiometer, and this is my Uno. This is my board, that's the potentiometer, and then you can see joint 5 is moving a little bit, and that's me moving it with the potentiometer, and it's finished because the step size is finished, the 80. I'll go ahead and do it again to a different, I'll go ahead and say 70 this time, and then we'll take joint 2. So over here with the potentiometer again, moving joint 2, the second one. Alright. I'll go ahead and press the push button to stop the operation. And as you can see, it says finished, which the operation stopped, and you can see I can't move it anymore because the operation was stopped by me pressing the push button over here on the circuit. Next, I'll go ahead and show you the photo detector, which is the light sensor that I have connected here with the resistor. The photo sensors work off voltages. As you can see, the room has some light in it right now, so if I run the photo detector, you're going to see some movement because it's picking up some light. It's sensing some photos, and with the light, it'll calculate some voltages and you'll see some smaller movement. But if I go ahead and apply more light to it, it'll give it more voltage and therefore making the arm move even more. Photo detector, enter step size 120. We've tried joint 5 and 2. Let's go ahead and try joint 4. As you can see, like I mentioned, the light was moving because You can see it's picking up some light from the room. As I apply more light to it, you can see more movement. All right. And then that movement will stop when I put my hand on it. Finished. Let me go ahead and show you again. With the Puma this time. And then we'll pick the photo detector, enter step size, we'll say 108, 160. You can put whatever step size is. Enter joint 1 to 6. Let's go ahead with joint 1. All right, we can see the small movement as I mentioned because it's picking up some it's reading some voltage. Applying more light, you see more movement. All right, now let's go ahead and cover up all that light with my fingers, and movement has stopped. Obviously, I'm not doing a great job. All right, there, stop. I'm applying extra, taking my fingers out, letting the step sizes go through, giving more light, therefore more voltages. All right, and the step size is finished. We'll go ahead and show you how I calibrated. You can see over here the calculations of the photos. Let's go ahead and show the calibration. Let's go ahead and go to my arm. You can go to any arm, it doesn't matter. All right. Just wanted to set it back. All right, so let's go ahead and calibrate. It says set and enter first angle value. So I'll go ahead and say 0 degrees. I don't have to move the potentiometer for right now, as we'll call that to 0 degrees. All right, enter second, we'll say 30 degrees. I'll move the potentiometer as I'm going 30 degrees. All right, and then we'll go ahead and say 45. I'll move it as I was going 45. Click 60, move it another 15. Go ahead and 90 on the fifth angle value. Let's increase another 30 on the potentiometer, and then enter 6. Let's go ahead and say 120, entering another 40. All right, okay, and you can see the best fit line is a linear, and it calculated 0 degrees, and then we set 30 degrees over here. As you can see, angle values from 0 to 360 degrees, and the potentiometer angle analog values from 0 to 1023, because those are the values that get calculated. You can see 0, 30, 45, 60, 90, 120, and then it gave me the best fit line. It works the same as the least square regression line. And finally, we'll go ahead and show you that I can move the joints again. And finally, Arduino disconnect, device deleted. So if I go to connect hardware, let's say enter 100 step sizes, and you can see an error over here because I need to connect first. All right, and that would be it.